Hello, this is Ms. DB, and in this lesson we are going to review how to do rotations. This is from Chapter 12, Section 3 of our textbooks. This is on our chapter on transformations, and in this lesson we're going to learn to identify and draw rotations. A rotation is a transformation that turns a figure around a fixed point called the center of rotation. A rotation is an isometry, so the image of a rotated figure is congruent to the pre-image. Our fixed point when we do the coordinate rotations will be 0, 0, just for the sake of making it a little easier. You can also, though, rotate about a point on the figure. Part of your worksheet is just going to be saying, yes, it's a rotation, or no. And if you say no, then say, is it a reflection? Is it a translation? Is it something else that you don't know what it is? So A looks like a reflection to me. But C, if you look at the red rainbow, it looks like it's been rotated about this point right here, and then rotated to turn into the blue rainbow shape. A does not look like a rotation, it looks more like a translation. And B, let's see, would that red triangle, if we rotated about this point right here, would it be exactly the blue triangle? It appears to be. It might be slightly different, but I think that it's accurate, so we would say yes, that's a rotation. If you're going to draw a rotation by hand, it's a little bit tricky. You would draw a segment from each vertex of the shape to the center of rotation, and then you have to make sure that the distance from each of those is equal. And you'd use like a protractor to measure the angle. It's a little tricky. Here's how you would do it. We're not going to actually do it for our assignment because it's too difficult in the online world to recreate these. You'd have to take a picture and scan them in. You can't really do it on the computer. So a rotation about point P, called the center of rotation, such that each point, remember A would be the pre-image, is rotated by this angle. That's a rotation here. So this point A has been rotated up to A prime by whatever angle they tell you. It looks like it's about a 90-degree angle. And its image, A prime, is the same distance as the pre-image was from point P. So it's going to be congruent location and size if it was a figure instead of just a point. The angle of rotation is from here to here. So angle AP, A prime, AP, A prime. All right, so let's look at how this is done. We have this figure right here, this blue triangle, and they wanted to rotate it about point Q. So you would start by drawing a segment from each vertex to point Q. Next, you would construct an angle congruent to angle A onto each segment. So this is angle A, and then we did angle. Measure the distance from each vertex to point Q and mark off this distance on the corresponding ray to locate the image. So they measured from here to here, here to here, and there's another line on top of that one from here to here. And then they put points on the lines at the same places, and then you connect it, those vertices, to create the image. We will do rotations just counterclockwise. They really can be done both ways, but we're just going to, in this textbook, we'll just be doing counterclockwise. Sorry, I think I said clockwise. Counterclockwise. And then here's another example. This is the same thing. You can kind of see the steps again. Again, you're not going to be doing this on your assignment. It's just for your knowledge about how it could be done by hand. You have to know this angle, though, and they're not even telling you what it is. So we are going to do these. We're going to do rotations in the coordinate plane. There is already a video in your folder about how to use Sketchpad for rotations. I highly recommend using Sketchpad for the second half of your worksheet where you have to do the rotations in the coordinate plane. It is so fast in Sketchpad that you will be happy that you did. All right, so rotations in the coordinate plane, 90 degrees about the origin. You are going to take the points of the pre-image, x, y. You flip the x and the y around, so the x-coordinate becomes the y-coordinate becomes the x-coordinate, and you take the opposite sign of what was the y-coordinate now is the x-coordinate. So xy becomes negative yx. You do that for every vertice on your image, your pre-image, sorry, and then you'll be able to just connect the points, and that will be your rotation 90 degrees about the origin. So it's a rule that you use. If you want to rotate 180 degrees about the origin, then you use the rule of xy becomes negative x, negative y. So you keep them in the same position. All you do is change both of their signs. So a pre-image that was in the first quadrant will end up in the third quadrant. Both signs will change. If it was down here, if they were both negative, they'll become both positive, and you'll end up here. You can also do rotations different than 90 or 180, and you would use sine or cosine. You'll learn how to do that in pre-calculus. I'm not even sure if we do it in Algebra 2. But in pre-calculus, you can use sine and cosine to do rotations. So it is possible. You can also do rotations by any angle using Geometry Sketchpad. So there's another advantage to that program. All right, let's look at an example in action. These are like your assignment, the questions on your assignment. You have several of these to do. So you start by drawing the pre-image on your coordinate system, and then you will apply the rule. So the rule for rotating 180 degrees is that you take the opposite sign of both coordinates. So j becomes j prime, and you'll take the opposite of both of its coordinates. K becomes k prime, L becomes L prime. Notice that a negative coordinate, when you apply the rule, becomes positive. So all the signs are the opposite of what they were before. They're not all negative. The blue is the pre-image. That is the original figure. We graphed it, and then we applied the rule to each of the coordinates, and you get the red. So this is a rotation 180 degrees about the origin. It's not the same as a reflection. A reflection, this vertice j would be up higher to j prime. So it's a rotation. It's been rotated about the origin. Here's another example, another 180 degree one. Remember the rule. So here's our original pre-image points. A is 2, -1, B is 4, 1, and C is 3, 3. If once we apply the rule, we get A prime is -2, 1, B prime is -4, -1, C prime is -3, -3. Then you graph both. You can also graph the pre-image first. I probably would. And that's the blue, and the red is the image. It is nice to use two different colors. In Sketchpad, you can do that just by selecting all of them and going to, I think it's display, and change the color. I do that in the video. All right, let's say that we have this word problem. A Ferris wheel has a 100-foot diameter and takes 60 seconds to make a complete rotation. A chair on the Ferris wheel starts at 100, 0 on the coordinate plane. After 5 seconds, what are the coordinates of its location to the nearest tenth? So to find the angle of rotation, we have to take 5 seconds out of a total of 60 seconds. So that's about 1/12, and there's 360 degrees in a circle, so it's gone 1/12 of the circle. This is arc length. And 1/12 of 360 is 30 degrees. So our angle of rotation is 30 degrees. So we start here at 100, 0, and we'll rotate up to there. Now, this is an example where it's not 90, it's not 180. So here's how, if you're interested, this is not a required part of the assignment, but to change or to find where our image is going to be, you would use this ratio, cosine of 30. Let me go back to the picture to show you. We're trying to find this point. It's a 30-degree angle, and you can make a right triangle by dropping straight down, and then you'll see that the cosine of this right triangle. Cosine of 30 is adjacent over hypotenuse. So the cosine of 30 is going to be equal to the adjacent side over the hypotenuse. The sine of 30 would be equal to the opposite side over the hypotenuse. So the x-coordinate would be 86.6. The y-coordinate would be about 50, which means that our point on the graph, go back here, come on, our point on the graph would be at 86 point whatever and then up 50. All right, moving on. Here's one more example of that kind of optional sort of thing. The London Eye, that's just a really big Ferris wheel that they have in London. It has a radius given, and it takes 30 minutes to make a complete rotation. Find the coordinates of the observation car after 6 minutes. So the angle of rotation is 6 over 6. Why is it 6 over 60? It says it takes 30 minutes to make a complete rotation. Find the coordinates of the observation car after 6 minutes. I would think that that would be 6 over 30. Because it's not 60 minutes to make a complete rotation, it's only 30. Let's just, maybe this is a typo and this is supposed to be 60. Okay, so we're changing this to 60 minutes. So we will use the right triangle again to represent the car's location. This radius is the same no matter where you draw it. So the radius of 67.5 meters is the same here and here. So we can use cosine of 36 to find the x-coordinate. And we can use sine to find the y-coordinate. So the cosine of 36 times 67.5 is approximately 20.9 for our x-coordinate. The y-coordinate is going to be the sine of 36, which is approximately 64.2. So our chair's location after 6 minutes is at approximately 20.9, 64.2. All right, so again, those last ones are a little bit optional, but the other rotation ones you should be able to do using Geometry Sketchpad or drawing by hand and scanning in, which I would recommend Sketchpad. Thank you very much and have a great day.